this video, I'm going to show you how to use the Asiga Composer software to import an STL file, nest it, support it, and send it to the printer. So to begin, I'm going to open up the Asiga Composer software, and I'm going to create a new build. Under here, I'm going to choose my target printer. So I'm going to choose the Whitmix printer here. Your printer name, it's going to show up under the Max UV385 or Pro 4K UV385 or whatever series of printer you received. It's going to show up under that list. If you do not see the printers under that name and you only see the virtual printers, you'll need to make sure that your printer is powered on and connected to the network that this computer is connected to. So from here, after I choose my target printer, I'm going to choose my material. I'm going to go ahead and select the Verimodel OS Ivory 20.1, and I'm going to choose the layer thickness I'm going to print the objects in. If I'm going to print a model that is for crown and bridge prosthetics or fixed prosthetics, so like an implant model, I'm going to almost always choose 50 micron layers. If I'm printing a model for, let's say, orthodontics or a removable prosthetic of some sort, I'm going to choose 100 micron layers. So I'm going to choose the 50 micron layers, and then from here select OK. Then under here, the next step is we're going to add our parts in. So up on the top left, we have add parts. I'm going to select that. And just a little tip, if you go to default, you can sell it to always auto place the structures we're importing. I always set that. You only have to set it once upon installation of the software. So from here, I'm going to select on select files, and I'm going to navigate to where my objects are. So I'm going to go to my desktop. Then I have a STL file folder, and I'm going to import in these crown and bridge models. So from here, I'm going to select open, and you can see it's going to try to auto place everything. Oops. So from here, I'm going to go and select open, and it's going to go ahead and import and nest all the structures for me automatically. If we look at it from a bottom point of view, we can see when I do this slight rotation, it's like this marbling camouflage effect. This is actually a sign that the objects are touching the build plate. I can print models with them touching the build plate. That is no problem at all. However, if it's a hollow model, you do want to make sure that the actual models have these portholes on them if you're going to be printing them to the build plate. If you are not, then you will want to place them on supports. Now, anything that has a flat surface you can print to a build plate like a model, but for example, surgical guides, dentures, splints, castables, RPDs, temporaries, those will all need to be printed off the build plate and on supports. So, to attach supports to our structures, the very next step is to go to Generate Support. Under Generate Support, there's a series of settings that have already been validated by the manufacturer. So you don't actually have to go in and change any of these settings. So I can actually go ahead and simply select Apply. Now before I do so, I want to make sure that I have all selected so it applies supports to all the structures I want. If it was just random structures that I wanted to apply supports, I would just simply select on Selected and then select the object I want. I'm going to select on All and hit Apply. So from here, it's applying all the supports to the structures. So from here, if I flip this over, I can see all the supports for my models and dies. This looks good. Let's say I wanted to come in and actually customize some of these supports or add more. I can simply select on Add, and then I can come in and add supports to where I want. Or let's say if I want to remove, I can select on Remove and then remove the supports. Alright, so look at it from a top point of view again. Just a little tip, to move the structures is to left click and hold, and to rotate the structures is to right click and hold on the structure itself. Left click on it once, right click and hold will allow for rotate. Left click on it once, then left click and hold will allow you to move. it's going to allow you to rotate or move according to the orientation that you're looking at it. So from here, just to recap, we have created a new build, we've added in our parts, we've added our supports, we did a little bit of nesting with moving it around and rotating it, and then the final step is to actually send the job to the printer itself. So I'm going to select on build. From here, the build wizard is going to open up. Under here, just gives generic information about the printer, let's say the name of the printer itself, the version of the firmware that's on it, and also on here it also gives me the material information, the layer thickness, and it gives me an opportunity to put the batch number in. This would be the lot number for the material. This is only necessary, for example, let's say if it is required by your state or country to actually regulate the material lot for medical devices. Since this is just a model, I'm simply going to select next. From here, depending on what version of your software you're on, you have the ability to turn on separation detection and fast print mode. If I have this turned off, we can see that the build time is going to take 1 hour 23 minutes. If I turn on separation detection, we can see it cuts off the 23 minutes. Now it's only going to take 1 hour. And then if I want to put it on high speed mode, which is just going to increase the mechanical movements of the printer, I can select fast print mode. So we can see it shaves off another 15 minutes. From here, anything that I print on supports, so we can see this is supported, I'm going to add a base plate thickness of about 0.3 millimeters. So I always go between 0.3 to a half millimeter. It's at your discretion on what you want to choose, but I usually never go below 0.3 millimeters. I also print with the shadow base, and I only have a base applied for supported parts only. So from here I'm going to select next. Under this software you have the ability to add in different print ranges. We're going to use a default range. We're not going to actually change anything or add or remove ranges. If we select on the advanced settings, it shows all the settings that actually make the material print for this printer. We're not going to change any settings. We're simply just going to select next from here. So we need to name the build. So Asiga demo. And then from here, we're going to go ahead and select send build. When we select send build, it takes the actual objects, renders them into slices, and then it will compile the slices together and then send them to the printer. The actual performance of your computer and speed of your network will change the actual processing speed of this actual step. So once this is completed, here in a moment, we'll have a final pop-up that says view slices. So when this comes up, I always want to view slices. So here we can see all the objects that are on the build plate, and this is the first layer. So if I press play, it will run through the slices. Now if I came in here and saw that I was missing an actual outline for an object or a first slice, that means I need to go back to the actual Composer software and re-nest my objects to make sure that they're actually touching the build plate. If I press play, it goes through the actual slices itself. It'll go all the way to the end. These are all the images that the actual printer is going to project during the printing process. So from here, the final step would be to actually start the print job. I'm going to show this on the printer web interface. So from here, I'm going to go to front panel. On the touchscreen of the printer, you're going to select on print, select build, and then here we see Asiga demo. We would select next, continue, and then if you actually want to start the print job, you would select yes, and it would actually start printing. This concludes the actual session for how to actually import, nest, and print objects in the Asiga Composer software.